Now in reaction kinetics, we have something called a pseudo first order reaction. A pseudo first order means it's like a fake first order reaction. Okay, that means it could be a second or third order, but because of certain circumstances, it could behave as a first order reaction. So let me go through the two cases in which this happens. Okay, there are two cases in which something can become a pseudo first order reaction. So for example, let's say you have a rate equation given by this, rate equals to K, CH3Br, and OH minus. Overall, it is a second order reaction. But if one of these reagents are in large excess, okay, so for example, if OH minus is in large excess, the concentration of OH minus will remain constant throughout the reaction. Okay, let me give you an example. So let's say A plus B gives you C. If A is 0.01 mole per dm cube, B is 10 moles per dm cube. Okay, at the start, let's do an ice table. At the start, you have 0C. So let's say after a certain time t, let's say half of A reacted, so minus 0.005. B will also minus 0.005. C will be plus 0.005. This will be 0.005 left. This will be 9.995. And based on this, you can very clearly see, sorry, this will be 0.005. Based on this, you can very clearly see that the starting amount of B is 10, the ending amount is 9.995. It is almost constant, which means if my rate equation is rate equals to KAB, the concentration of B remains almost constant throughout the reaction, which means I can replace it as a K prime A. Okay, B will be a constant. It can be subsumed under the same constant. Okay, similarly, if OH minus is in large excess here, so my OH minus is in large excess, it can be replaced and subsumed under the K, where we can let it be a new K prime, where K prime equals to KOH minus. Okay, so now when you subsume the OH minus under the K prime, this overall equation, overall order is now first order, which means it's now a pseudo first order reaction, and this will allow you to do several things. For example, you can measure the half-life where T half equals to ln 2 over K prime, where K prime is KOH minus. So it allows you to use first order equation graphs. It allows you to find half-life, okay, because the constant half-life is only applicable for first order reactions. Now, another scenario in which you can get a pseudo first order reaction is when one of it is a catalyst, because you know a catalyst is not used up within the reaction. So for example, H plus is the catalyst. So if the H plus is the catalyst, the concentration will remain constant throughout. We can rewrite that as K prime CH3 CO CH3, where your K prime is equals to KH plus. So now, once again, this becomes a pseudo first order reaction, and then therefore all the rules pertaining to first order reactions can apply in this scenario. So once again, this is 1 minute of chemistry. See you the next time.